everybody. In this video, we're going to talk about critical points. Critical points are very easy to find once we've mastered the ability to take a derivative. So just remember that a critical point, it's any number in the domain of a function where the derivative of that function equals 0 or it doesn't exist. So very easy for us to be able to find if a function has critical points or not. The first thing that we need to really make sure is that the function is continuous over the domain. And once we take the derivative, we set it equal to 0 and we solve. That's our steps. Super simple, very quick. Now, if our function doesn't exist within that domain of the derivative, then we don't have any critical points. And sometimes that's very easy to see in the very beginning before we even start the problem. And we'll see an example of that in just a few minutes. So going ahead, let's look at example number 1. So we have f of x equals 3x squared plus 2x minus 1. What I want to do is I want to just do my two simple steps. Step 1, I want to take the derivative. So when I take the derivative of this function, we wind up with 6x plus 2. And then step 2 tells us to set the derivative equal to 0 and solve. So when we solve for x here, we're going to get x equals negative 2/6, or when we simplify, we get x equals negative 1/3. And that's it. That's our critical point of this function. I know looking at f, it's continuous, the domain, and everything is going to work out so that we have our critical points. It's very simple, very straightforward. Looking at this example, this second example, we know that g of x is continuous throughout its domain. I know that when I take the derivative here, we're going to wind up having a critical point. So this is a chain rule problem. It's going to be a little bit more in-depth than the last derivative, but still very simple, very straightforward. So step 1, we're going to take the derivative of g. And so we get 4 times 3 times 4x plus 1 to the third power times derivative of the inside stuff, which is just 4. Go ahead and simplify this out a little bit. We get 12 times 4 gives me 48. Plus 1 cubed. And we're going to set it equal to 0 for step 2. So go ahead and start solving it out. Divide both sides by 48. We get 4x plus 1 cubed equals 0. Take the cube root of both sides. I get 4x plus 1 equals 0. Go ahead and subtract 1 from both sides, divide by 4, and we get our critical point at negative 1/4. So again, very easy, very straightforward. Following my two steps, I take my derivative, then I set the derivative equal to 0, and I solve. Finally, our last problem here, it's a rational function. So now I'm kind of asking myself, okay, is there any point of x where the function does not exist? And if I take my denominator and I set it equal to 0, we're going to wind up getting 1/2. And so we know that at x equals 1/2, our denominator is going to equal 0 and our function becomes undefined. Well, because it becomes undefined there, we know that the derivative, the domain of the derivative is never going to equal 0. Therefore, we will have no critical points. And so without even having to do my steps, we can just go on and say this function has no critical points. And that's it. So I hope this video helped you guys understand critical points a little bit more. Very simple. I know that the examples were pretty simple, but again, just follow the steps. Take your derivative, set your derivative equal to 0, and solve. That's it. Check out the domain of the function. Make sure it exists everywhere within the domain. And if it does, you've got critical points. If not, no critical points exist. Appreciate you guys checking out the video. I'll see you next time.